Hello, this is Dr. Z. This video is going to be a test, both of the microphone and also of the recording. I'm going to be recording some of the basics of programming from Chapter 2. Now, in most cases, I will have some of the header already created, but just to show you, whenever you start a new Colab document, give it a name up here. Put in comments at the top your name, the date that you started working on it, and the name of it and a short description of what's going to be in there. Chapter 2, data types, operations, input, and output. Okay, so I'm just going to go through, as I've said in class, this first video this semester is an experiment with this. The video is not going to be very edited. This first video is going to be a trial, and I'm going to want you guys to watch it and see how well it works out. Okay, so we talked about some of the data types in class. We talked about floats, we talked about ints, we talked about strings. So an integer is a whole number, positive or negative or zero. A float is a real number. It can have decimal places, and a string is text. So if I want to assign a float, it would be something like, an int, num1 equals 6. That's an integer. This is an integer assigned to the variable num1. Num2 equals 8.3. This is a float assigned to num2. Now, if you want to force something that's an integer to be a float, you could do something like 5 point. This is the number 5 made to be a float by the decimal mark. Oh, there we go. Word 1. This is a string with single quotes around it. Word 2. This is another string with double quotes around it. You can have symbols in there. You can have spaces, uppercase, lowercase, etc. Word 3. Bob's Diner. If a string has an apostrophe, you must use the double quotes around the string. Otherwise, you can use either one. You can use single quotes or double quotes, but if your string includes an apostrophe, you must use single quotes. So that's the short data types. Now we'll talk operations. We did this in class, but I'm going to do it again. Oh, I want to show you what some of these look like when they're printed. Print num1, print num2, and print num3. Print word 1, print word 2, and print word 3. Again, I mentioned this in class, the very first time that you run code in a new notebook here, it's going to take a little while because it's doing this initialization. See, it printed 6, 8.3, and because this is a float, 5 point, it prints it as 5.0. We will talk later in this video about rounding. And you'll notice for the strings, it does not show the quotes around it. It just prints the text. Okay, single operations. So these are things like plus, minus, negative, and so on. Num1 equals 10. Num2 equals, I don't know, 7. Now, just as a note, this won't matter that much right now. In the same notebook file here, even in different blocks, the variables keep their values. So num1 is 6 until I change it here, which means that down here, num3 is still 5.0. Okay. Now I'm just going to print these out. Just by printing them, you don't actually change it. It remembers from a previous time I have done this. So I'm just going to do this to save typing time. I'll talk about that in a minute. I'm doing this to save typing time. So addition, subtraction, multiplication with an asterisk, regular division, integer division, you can also call it truncated division, which is what the book uses. Modulus, which is the remainder after dividing. And num1 double asterisk. Num2 is exponentiation. I think that's all of them. Let me double check really quick my notes. Oh, and the negative. I'll do negative at the top. Print negative num1. Negative. And as I mentioned in class, also the value, this does not change any of the values in num1 or num2. Num1 is still 10, num2 is still 7. They don't change unless you change it with the assignment operator equals. So if I run this, negative num1 is 10, num1 plus num2 is 17, num1 minus num2 is 3, num1 times num2 is 70. This is 10 divided by 7 is this. We'll talk about rounding later. 10, the double slash, the truncated division, it takes just the whole number part. Modulus, 10 divided by 7 is 1 with remainder 3, so modulus shows the remainder. Modulus is actually really, really useful in certain applications, which we'll talk about later in the semester. Huh. Interesting. I didn't see this before. We can ignore that, though. And then 10 to the 7. There's operations. So this is as far as we got in class this week, but I want to add a little bit more because I want to talk about inputs, or one more thing I forgot. Let me put up here. Type num1, type num2, and type num3. Type word 1, type word 2, type word 3. I'm going to rerun this. Okay. This is something I forget that Python does. The type function only shows the very last type in a code box. So I'll have to show you this live. Type num1 is an integer. Type num2 is a float. Type num3, which remember was 5 point. That's a float. And then word 1, word 2, and word 3 should all be strings. String. So if you're ever not sure, you can use that type function, which will show what the type is. That's mostly used for just checking some things occasionally. As you saw, when I entered in type 6 times, it only showed the last one. So the type function is only going to display one thing total at a time. So it's not useful for actual use in code running, but it's useful for testing some things. Okay. next I wanted to talk about inputs. Or no, expressions. Sorry, expressions. Order of operations. Python uses regular order of operations. This is table 2.6 in the book, where first is exponents, then negatives, and then left to right multiplication, division, truncated division, and modulus, and then left to right addition, subtraction. It is standard algebraic order of operations. Just like in algebra, you want to use parentheses if you're not sure. The only exception to that is exponents. I'm going to show this in the code. Order of operation with exponents. So I'm going to do 2 to the 3 to the 4. So first I'm going to go print 3 to the 4, just so we can see what that is. 3 to the 4 is 81. And I'm going to go print 2 to the 3. That's 8. Print. Now, if we were to do this by hand, this goes right to left with exponents. So we're going to do 3 to the 4. If I do this all in one line, we'll do 3 to the 4 first, 81, and then do 2 to that power. So 2 to the 3 to the 4. 8 to the 81 is that. I want to grab my calculator out of my bag. Actually, I don't have to do that. I will just compare. Print 8 to the 81. Well, that's not the way it's supposed to go. I followed the book, and did the book steer me wrong? Sorry, not 8 to the 81, 2 to the 81. Can't do it twice. 2 to the 81. 3 to the 4 is 81, and then 2 to that. So this is the same as 2 to the exponent, parentheses 3 to the 4, like that. You can do that. Except I did times instead of exponent. There we go. You can do that way. In fact, if you are unsure about order of operations, you should always use parentheses. If you want to do 2 to the 3 first and then that to the 4, you have to do parentheses 2 to the 3 and then that to the 4, which should be the same as 2 to the 3 is 8. And it is. So order of operations with exponents is right to left. Everything else is generally left to right for the equivalent level of order of operations. Okay, now I can talk about input. We've got some other data types I'll talk about in class. Data types like bool, lists, tuples, and so on. But we're just going to deal with a few things about operations. Also, operations only work on numbers. If you try to do an operation on a string, let me put a note here. If you try to do an arithmetic operation on a string, it should give an error. For example, if I try to do print word 1 divided by word 2, error, and it specifically says unsupported operand types for division, string and string. So you cannot divide strings. I forget if you can add them. Some languages actually let you add strings. Yes, it will let you add strings. We'll talk about string stuff in the future. I'm going to keep this as division for now to show one that does not work. If you saw that briefly, that's fine. We'll be working on that in this chapter about strings. Okay. I want to go ahead and talk about input now. So I can do something like, let's see, input. Format is variable equals input prompt, like that. So for example, I can say name1 equals, I'll just call it name, equals input, quote, what is your name? And then I'll just leave that as is first. That's the box. Now if I add print name, if I run it, asks for my name, and it will print my name that I just entered. Generally, just to make it look pretty, question mark in space or like a colon and a space, something like that, to separate this from the box. If you want to do a number, however, if I were to do something like num1 equals input, enter a number, then print num1, but I'm also going to say what type is num1. So what is your name? Enter a number 12. Num1 is a string. So this is not the number 12. This is a text box where the characters are read 1, 2. So this is a text. By default, input always gives a string. If you want it to not do a string, you have to force it to not be a string. To input a number, you must force it to become a number. So I need to do something sort of like num2 equals int parentheses input, enter a second number, print num2 type num2. Remember now the type for num1 is not going to show anymore. It's only going to show one type total. Name the number 12. Second number 67. Now it's an integer. And now you can do math stuff with it. This right here, I will tell you right now, I'm not used to this. That's a very common mistake that I make when I'm doing. I will always forget that. So I'll just do input, and then it'll give me some weird error, and I'll have to go back and remember, oh yes, I have to make it an integer. Just to prevent it from being too cluttered up, I'm going to put a comment in front of this. This is called commenting code out, by the way. The code is still there, but it doesn't run because it's behind a comment. And then I'm going to do num3 equals int input, enter a third number, print num3. And then I'm going to do something like print num2 plus num3. Name, this is the text number. I'm just hitting my numbers randomly. 87, 34, add them together to get 121. That's how we do inputs. However, we might want things to look a little bit nicer. We might want to do something like print the sum of your last two numbers is space, comma, num2 plus num3. I'm just hitting randomly. 109. Oh, I don't actually need that space there. It automatically will put a space in. Python does that. Some languages don't. I'll take that space out. This makes it look a little bit nicer, and you can do multiple things. You can do something like print the sum of, comma, num2, comma, and, comma, or parentheses, num3 is num2 plus num3. And you can see it says the sum of 77, num1, and 34, num2, is 111. This makes it look nicer. As we get to more, even just slightly more complicated programs, you want it to look a little bit nicer. Okay. The last thing I want to show you is rounding format. Okay, rounding in display. Go away box. Okay, I'm going to use a number we all know, pi. I'm going to call this just num pi. I can't just use pi because that it might let me do it, but don't get used to that. I'm just making a number called pi. 3.1415925. That's as far out as I will go. Now I can do print num pi like that, and it prints the whole thing. Let's say I want to round it so I can do something like print format num pi, comma, let's round it to 4 decimal places. 0.4f. Oops. I did something wrong. Oh, it needs to be in quotes, I think. There we go. I forgot to put that. This has to be in single quotes. So print format numpy 0.4f. Notice that it actually does round it. It doesn't truncate it. 3.1416 to round it. This rounds, not truncates, to 4 decimal points. Now what's this 0.4f? You could leave the 0 off if you want. The number in front is the total amount of space it requires. So let's do something like this. Format num pi 15.4f. You notice it spaces that out. This gives 15 spaces for the number and aligns it right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It uses up 15 spaces. Let me add this here. It will always use up at least that many spaces. It will not limit it to that many spaces, as seen when we use 0.4f. Now, 0.4f means it's floating. If you want to force it to be an exponential form, I don't do that much, so I hope I type it right the first time. Let's do like 0.4e. I think that's the right way. Yes, it will do it in scientific notation. Because this is already a number between 1 and 10, it's technically in scientific notation. So let's do large number equals no y's. I'm just hitting a bunch of texts, a bunch of keys here. I'm going to copy this down here instead. It would help if I do this large number. Notice it does 4 decimal places because I told it, and it's in scientific notation. So this is 5.6990 times 10 to the 12th. This puts the number in scientific notation with the given number of decimal places. Okay, and that's how we do rounding. I'm going to go ahead and end this first video here, and hopefully it goes over well.